Hare Krishna. Hope you are doing well. Let's get started with this question on simple linear regression and an element of estimation. Okay, it may look slightly bigger than other questions. You are given this simple linear regression setup where yi is a random variable, xi's follow a certain structure, and not just the least square estimates, least square estimators. You have to look at the covariance and variance of that. So it's a two-dimensional, two-layered problem. That first you must know the estimates, or sorry, estimators themselves, and then you bring in the stochasticity angle around their variances, covariances, and all of that. But nothing to worry about. Let's get started. In regression based questions, at least in these competitive examinations, being grounded on the basic theory is enough. Knowing that the variance of the estimator for the slope parameter is of this form, it has this value, variance of the intercept estimator has this, and the covariance of the both of them have this structure. Having this knowledge is sufficient. And suppose in a ISI PSB like question, you sort of forget things. But even if you remember that essentially beta 1 hat is given by, summation xi x bar y bar divided by summation xi x bar whole square, and beta naught hat is essentially y bar plus x bar beta 1 plus or minus, one of them, one of the sign, either plus or minus, but yeah, this is it. Then if you have the form, you can on the spot also derive the variance of beta 1 hat, because you can see when you take the variance of this thing comes out of the variance, and it can be sort of exactly this thing is what I'm trying to say. You can also come to the derivation in a PSB like question if needed, but it's always good to know these formulae to proceed. And for this particular structure of xi's, essentially it is telling us x1 is -1, x2 is 1, and this -1 pattern goes all the way up to x20 where it is 1. So you may be able to see there are 10 values of -1, 10 values of +1. Best case scenario possible, the sample mean is 0. And uh, that is why a lot of things become easy for us, because the sample mean is 0 over here. This part in the numerator becomes 0, so variance beta naught hat becomes essentially sigma square by n. And because this is 0, this thing sort of vanishes over here for the context of our problem, and this becomes summation xi square. Now xi is -1 or 1, so xi square is 1, summation of 1s is going to be n, so it's sigma square n, so both of these are the same. Covariance of beta naught hat and beta 1 hat is this thing, x bar is 0, so this becomes 0. This is correct. As for these two, now they may look mm, above average complicated, let me call it like that, but we can see that this thing will turn out to be this. And the intuitive way to go about it is taking help of the way covariance operator can be broken down linearly and be simplified. So maybe the first instinct would have been to do something like expectation yi hat beta naught hat minus expectation yi hat and expectation beta naught hat. So this would have been a very complicated way. But if we just expand yi hat is what? It's the prediction, right? Prediction part is exactly this. And then using the linearity of covariance, this thing becomes covariance of beta naught hat with itself, which means the variance of beta naught hat. And this thing is this xi would come out and covariance beta 1 hat and beta 1 hat, but we already know that this thing was 0 given the specific structure of our problem. So this thing is indeed equal to the variance of beta naught hat. So this is correct. And for the other part, which is checking this option, we go a similar route, and this is where it can get, you know, slightly tricky. That's why I put it under this section. When we expand it and see this part, we get, which is basically 0, and this part, this thing will come out and it will become variance of beta 1 hat. And if we are not careful, we may bring it out as xi square and leave it as covariance beta 1 hat with itself. And this we may see that it's either -1 or 1, so the square is 1. But that's a mistake. When you have something inside the variance being taken out, then it becomes a square. But something inside the covariance which is present on one of the two inputs to the covariance, when it is taken out, it is taken out as it is. So this is something very important to note. So this thing is actually this, and it is not necessarily variance beta 1 hat. Sometimes it's plus, sometimes it's minus variance beta 1 hat. So this is not true, but the other three are true. And that's it. Take care. Hare Krishna.